So a regular polygon, we need to know what that is first. This goes way back to chapter 6. So I'm going to flip back for a moment. All right, if I flip back to chapter 6, those of you that had me in try 2, we talked about that word regular. Regular means it's an equilateral and equal angular. What does equilateral mean again? Equal what? That prefix equa means equal. Hey, gentlemen. Lateral means what parts are equal? The sides. And then equiangular means equal angles. Okay, so there's like our square, our equiangular or equilateral triangle. We could have our hexagons, pentagons. Okay, so regular polygon is equal side lengths. And equal measure angles. Angle measures. I don't know, I said that backwards. Okay, equal side lengths and equal angle measures. Alright, we're going to have a glue in. We're going to talk a little bit about some vocabulary that goes with our regular polygons, and then we are going to do just one example together. So, when you glue this in, make sure you glue it in on either the left or the right side. You do not need to cut it. Having these formulas down are going to be really important for your test. The test is going to be hard to do if you have none of the formulas.
Mine?
Test is on Friday. Not Friday. What did I just say? Monday. Why is it not working? This is just the way it worked out. I moved that other test. Hey, go ahead and do this. I have my hair. Nice job. I did update some of them. I saw you do some of them. You did some over the weekend. Alright, here we go. So get this glued in. Got a lot of people catching up over the weekend, which is great. Oh, we need focus. Alright, we are going to use some colored pencils here. Alright, I'm going to be using green, red, orange, and blue. Green, red, orange, and blue. I'm going to use, if you'd like to use other colors, that's fine. We have a couple more definitions to do, and then we just have one example. Shouldn't take us too long. Okay, Chloe. Here you go. Start writing down formulas so you have them. Okay, refocus here. Ready to go in about 15 seconds. All right, here we go. So, as we take a look at this, How many sides does this first polygon have? Okay, guys, put your computers away. This literally is going to take maybe 10 more minutes and we're done. How many sides do we have? 5. Does anyone remember what we call a 5-sided shape? We have names like decagon, nonagon, octagon, sectagon, hexagon, pentagon, quadrilateral. How many sides is this one? It's 5, so it's a pentagon. Good. Hexagon is 6. You're close. Okay. All right, so this is a regular pentagon. Shh. Oh my goodness, you guys are really throwing me off my game with all the talking going on. How about we just refocus here? It's not going to take us that long. Okay, so a couple of things we have to talk about a regular pentagon here is we have a center. Similar to a circle center, the pentagon, the vertices are the same distance away from the center. So in this case, what is our center? What point? P. What? No. It's not going to. Okay, then.
Are you sure?
Yes.
100%?
Okay, I'm trying to teach. Alright, radius. Just like a circle, we have a radius in polygons. A radius connects the center to the vertex. Okay, so our center to the vertex would be P2A or P2B. Okay, and the reason why those are radiuses is because it goes to the vertex, and if you look at the circle goes to the vertices, not the sides. So our radius here would be AP, or we could call it PB or PA, either way. Okay, and really we could draw those triangles everywhere. So how many of those triangles are created? There's 1, 2, 3, 4, and 5 of those triangles if we drew all of them. Okay. Oh my God. All right. This is our new word today is apothem. Now, Mr. Varst and Mr. Veroniak, those of you that know them, have a debate going. Mr. Veroniak calls this an apothem, and Mr. Varst says, no, it's apothem. And I looked it up on Google, and Google says apothem.
Can I get a pencil?
Yep. It's a really weird word.
Okay.
All right, apothem. And an apothem goes from center to the side, and it hits it at 90 degrees. So center to side at 90 degrees. I'm going to use green for that one. So our apothem here would be from P, and then it goes to the side here. We don't have a letter there, so we need to make one there. Let's make it M. So we'll put an M there. It's a really bad M. Okay, so our apothem would be PM. It goes from the center to the edge, and it hits it at that 90-degree angle. All right, so now we have enough information. We should be able to find the area formula for a polygon. So our area, A, equals, what shape is this made out of? All polygons can be drawn with triangles. And what's the formula for a triangle? A equals 1/2 base times height. So we keep the 1/2 for the triangles. Our height of the triangle is that 90 degrees. Remember, the height is always there. So we're going to actually do the height first, which is weird. And then our base would be the side. But our side, how many times do we have that triangle? 5 times. So if I take that side times 5, what do I actually get? The perimeter. So rather than doing the area of a triangle and then times 5, we just do it times the perimeter. So A, and then we use capital P for perimeter. We could just do 1/2 and then this side length times the height and then multiply it by the number of triangles, but if we just do it with the perimeter, it does that all in one step. So this lowercase a stands for apothem. And the capital P stands for perimeter. Samir, bruh, exhausting. All right, so as we take a look at this next one, that's pretty straightforward. That's really all we need is the apothem and the perimeter. And then when we do that, that'll find the area of all the triangles put together, rather than just finding one triangle and multiplying it by 5. If you want to shade in that triangle to kind of see that that's what our goal was to find the area of each of these triangles. All right, so as we take a look at this next one, we need our apothem and our perimeter. Those are the two measurements we need to identify in order to find the area. So I'm going to do an A and a P. What is our apothem here? 8. Good. It goes from center to edge and it hits it at 90 degrees. Okay, now our perimeter. Yeah, it's 5.8 for a side. And remember, this is a regular polygon, so how much are all the sides? They're all 5.8. So a couple ways we could do this. We could literally write 5.8 on each of these sides. 5.8, 5.8. You're right, it is too much time. So instead of writing it 5.8 all the times and adding it together, how many times are we doing it? How many sides do we have here? Do we have 8? I think there's 9 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to do 5.8 times 9, and that's our number of sides. Okay, 5.8 times 9, we get 52.2. Okay, so now to find area, A equals, it goes 1/2, and then we do our apothem, and then our perimeter. So we're just filling those in. What was our apothem? 8. And then our perimeter, 52.2. When you put this in your calculator, how can I put 1/2 in my calculator? There's a couple ways. 1 divided by 2. What's another way of putting 1/2 into my calculator? 0.5 would be another way to do it. Up to you. So 1/2 times 8, which what's half of 8?
2.
4. And then 4 times 52.2. What do you get, Lang? 208.8. Now, in this one, we don't have a way to measure it. It doesn't say inches or feet or centimeters. So what is our general word to describe all measuring things? Units. Good. So we're going to do that units with that little squared because it's that area, but still square units. And what that means is whatever we were measuring this in, if these were inches, this is inches. If this is miles, this would be miles. It's just telling us that whatever we measured this in, we are now measuring this in. Okay, here's the dealio.